All right. Hello, everyone. Welcome to the second session of our time series, Introduction to Time Series workshop. I don't know if you guys participated in the first one. In the first one, we studied together how we can actually manipulate pandas data frames. We were trying to see how we can prepare the data sets for time series analysis. Today, we are going to continue with, again, data pre-processing. I'm not going to talk about any particular time series models. I think pre-processing the data is, it's not, I think, it's very important. It's going to be very time consuming. So today, again, we are going to continue with how we can load time series data sets, how we can parse the data type, especially if the time is given in text as an object data type. So how we can change that data type into time data type, and then how we can work with that, how we can shift, how we can resample, and then maybe if we have time, we can continue with how we can interpolate to fill in missing values in a time series data set. Okay, so I shared the link to the material for today. Again, as more people join, probably let me copy this. So probably they're going to ask for the link. So I shared the link with you. Please go ahead and then I'm sharing one more time. Please go ahead and then download the material for today. Last week I uploaded the file from last week, so you can also have access to all the whatever we did during the session. You can have access to that file as well from last week. So if you have not participated in last week, I will also share the material from the first week as well. All right. Yes, this session is recorded, and then the recording will be shared. Okay. Oh, you can only see top of my head. I'm sorry. I cannot see myself. Oh, it's fixed. Okay. All right. Now you can see me, right? That's all right. Okay, so let's get started. So again, I got these data sets from different sources, some from what is that tutorials. So I put together. Okay, so it's not all mine. I put together the credit is not mine. I put together different the files from different tutorials. We're just going to study them together. Okay, so let's first load the data set. Okay, so for that I'm going to import pandas. Again, I'm assuming that we are totally new into this. Those who are already an expert on pandas, so may not be so appealing for you. I'm assuming we are all new into this. Okay, so I'm going to load the daily total female births data set, this data set. So PD dot. Okay, so let me say this is the birth data, right? And then it's daily, it's a long name, but daily total female, birth dot CSV. Okay, so that is the data set that I want to load. So let me get rid of this part so that you can see my screen. All right. Okay, now let me run this. And I would like to see how the data set looks like. So birth data.head, right? So here are two columns, date and births. So if you like, you can see the tail as well, right? These are the first 5 observations, and these are the last 5 observations. I have 365 observations. It's 1 year of data set. How do I know 365? The index of the first. Let me print the head one more time. The index is 0, and as you see, this is the date. This is the birth data of year 1959, and this is I think it is this is the month and this is the day, right? So again, let's see birth data dot shape, right? So we have 365 data points. And then birth data dot info. Okay, so I'm just checking my data set, I have 365 non-null data points. So whenever I teach or work on any project, please do not trust totally on this non-null report. So the data set might have non-null, might report as non-null, but the input, the data that is entered may be not relevant or totally uh, um, off the limits. Like, for example, the births here, 35, 32, 30, 40, 50 makes sense. But if the number is here like 3 million, right? So in that case, that number doesn't make sense. Even though it says non-null, that number doesn't make sense. That's why it's always nice to check the describe, right? So birth data dot describe. If there are any numeric columns, at least check what is the mean, what is the minimum, what is the maximum. So as you said, the numbers are, the minimum and maximum numbers are around the mean, so it makes sense. I don't have any millions or thousands here, right? So I don't have really the series outliers in this case. Anyways, so that is my birth data. And I have two columns. One column is date, the other column is births. Another thing info gives us is the data type of each column, right? So the data type for the births column is integer, right? However, the data type for the date column is an object. So in other words, date column, even though it is date, right? So it is actually the values of date column, each value of the date column is a string. Okay. So what we can do is, well, we can choose to have, what is it? What if I want to have the date column turn from an object into what is that? Date format. So what if that's what I want to do, right? So just 1 second. So please, if you have any questions, let me know, all right? If you have any questions, let me know. Why is it a CSV? Why can it? So we can work with a CSV, we can work with an Excel file. Most of the time you will find CSV files. They are a lot more smaller. And so you will have most of the time the file in CSV format. But it's okay, you can read an Excel file too. It's just change the CSV to Excel. You can read it in Excel file. Okay, so this is one way of loading the data. As of now, all we did is we loaded the data and then we checked the type of the data. We saw that the births is, even though, I'm sorry, date is, even though it's date, we know that it is a date, but the type of the data is for birth, for date is, I'm sorry, for date type, data type is an object. So I'm going to show you different ways of changing the date type. So another thing I want to do is, okay, so now I'm starting to work on this date column. We'll do this in two ways. First, let's learn the simple way, and then let's learn the more difficult, but not too difficult, but more difficult way, but gives us more flexibility, the second way. So what I want to do is, rather than using these numbers as indices, and remember this from our last session, indices, I would like to assign date as my index, so that I can refer to each birth number using the date. All right. So that's one thing that I want to do. Second, as I make date column as the index of my data frame, I also would like to change the data type from, in this case, object to date time. Okay. So I can do this as I am reading the data. So I'm going to copy this. Okay. I'm going to copy this. And please, you also do so. And put it in here. There are some, yeah, if the date format is, so we are going to slowly talk about that step by step. Yeah, date format, you can change date formats, you can do that. Okay, let's continue. So what I'm gonna do is, now I'll go step by step, okay? I'm going to say right now the index is 0, 1, 2, 3. So those indices are automatically created when I'm reading this data frame, right? When I'm reading this data from the CSV file, and and assign it to a data frame. So these index numbers are automatically created. So what I'm gonna do is, you know what? Don't do that. So I will say index column is 0. That means when I read the data, okay, let's see how our data looks like. Don't create a new index column in here. Just take the first column as the index. Okay. All right. So let's see. So as you see now, the first column, which was date, became the index. So can we also do this? Index column is, can specifically assign a column as the index. Yes, right? So it doesn't have to be the first column. If you like, you can specifically say the index column, when you read the data, make sure that this column is assigned as the index column. Okay, so now I have my index column. So let me add some more. Now, I would like to see the birth data dot index. Okay. So again, my indices are of type object. Okay. So I have, these are the indices now. So what does that mean? So I can say birth data dot log. I'm gonna say what? 1959. Okay. 0103. So when I do this, I am referring to this third row, but it is not third row. It is the row with index value 1959-0103. Okay. So, and then the dirt number is 30 for that. So you can either, remember we did this last time. I just want to remind you one more time, or you can do this iLog. This time I'm gonna take the third row. Okay, I'm gonna take the third row. So this is the third row and everything, right? You see now, again, I got the same row, but this time I'm using the index value, which is index value for this one is 0, this one is 1, this one is 2. This time I'm treating this data frame, and then this iLog is using the index of this, call it as a table. Okay, so the first row has index 0, the second row has index 1. If you don't know index, specific index values, then I can use the order as the index. So 0, 1, and 2. I'm using the order as an index. So this time 2 is the order of the third row, which is 1959-0103. Okay, this was from last week. I just wanted to remind you. Here, today, what I want to do additional is, I want to turn this index value into a date time. That might give me some flexibility. And kind of flexibility, what kind of flexibility? We'll see in a minute. Okay, again, let's go step by step. I'm gonna copy this. Please do so. And paste it in here. Now I'm gonna add one more thing. And by the way, let me see. Yeah. Index is supposed to be unique. Otherwise, you cannot refer to index, right? Index is supposed to be unique. Okay, so I know how to assign a specific column as the index. Now what I want to do is, I'm going to, if the index is a date, okay, I'm gonna make sure that it is turned into date. So again, we're gonna do this in different ways, but parse dates equals true. If there are any date columns, make sure that they are turned into, what is that? Date format. So let's see what happens now. Let's see what happens. Again, I only added this one. Okay. Now I will check my data. Let's first check the info. Again, this time I have one column because index is, I turned date into index. That's why I have only one column, births. Okay. But look at the index here. You see, index is not index anymore. It is date time index. I turned date index into a date time format. So what is the significance of that? So what, right? So you can ask me, so what? What happened now? So what I'm gonna do now is, okay, actually I should have called this B data too so that we could see the difference, but anyways, let me not confuse you guys. So remember how I selected, yeah, let me do it that way so you can see the difference. Sorry about that. So I just want to make sure that we see. I'm going to call this B data 2. Okay. So that B data is this one, where index is of object, and B data 2 is this one where index is of. So again, let's look at the indices of B data 2. It is now date time index. This one was each index value is of object, is a string. Here it's of date type object. Okay, so now what I want to do is I'm going to take from my data, I'm going to select, you see, my data is giving me daily number of birds, female birds in year 1959. So what I want to do is, for example, can I slice my data for all the birth numbers for the month of January? Okay, that's what I want to do. I want to slice my data for only the month of January. So there are different ways of doing this, of course. Always there are different, but one of the ways I can do is I'm going to use LOC, log. You see why I'm using log? You remember I'm using LOC, log, because I can use the index value, right? Index value, not the order, just specific index value. So this time, what I'm going to do is I'm going to say, give me, okay, the birth numbers in year 1959 in month 01. Let's see. You see, now it gave me all the birth numbers in month 01. So this is the first day of January in year 1959. This is the last day of January in year 1959. Now, the question is, can I do the same thing if I had not turned my index value into a date format? So let's add here. Remember this one. B data is, so remember B data, the index is of object data type, is of object type. So I'm going to do the same thing. B data dot LOC 1959. It's actually 1959. Okay, it's not 1959 here. 01. You see, it didn't give me what I was expecting. It says key error 19, because right now it is looking for this specific index value. There is no such an index value here. So you see the value of turning my index type from object to date type, so that I can use date, right? So I can summarize my data only referring to a specific month. For example, I can say 1959, give me all the birth numbers in April. Right now I have the date, I'm sorry, the birth numbers in April. Okay, so that is one nice thing about date types. Now we're gonna learn a little bit more about how we can change, what we can do with this time with these indices once I turn them into date format. So now I'm gonna continue with the second data. So here, let me go from here. Okay, and then let me see if you guys have any questions. Yeah, you can download them. What if the data is there a way to do the same? What if the data passes April? Yeah, so there are different ways we can handle data. I'm sorry, date format. So let's get to that step by step. All right, maybe I don't know, maybe not today, but we're gonna get to that step by step. It's extremely important. If you're working with time series data sets, you have to be extremely comfortable with working date, because everything is about date. So time series is just a date. It's a data with time being its dimension. If you remove time from a time series data set, it's not time series data set anymore. That's why we have to be very comfortable with date data type. Okay. Yeah, you're going to get the Jupyter notebook of this class after the lecture. I'm gonna upload it to the same folder I shared with you. All right, now let's do another a very same thing. This time I'm gonna be importing this minimum temperatures, okay, minimum temperatures. So let me first type it. So ed.read CSV, daily minimum temperatures, okay, .csv. Okay, so I'm reading this. Now I know that, well, I can make this, I know that, right? So index column. If I say 0, the first index, the first column will be, before doing this, I would always read the data first. Let's say data frame is this. And then let's see how data frame looks like. Sorry. Yeah, now I have a date column. Okay, that is the first column. If you like, then you can say index column is 0. When you say index column is 0, I'm not gonna, now I know that, right? The first column will be the index, which is date, or you can simply say make the date as the index column. Okay. Another thing we learned is I can also turn this date into date format. So parse dates. Perfect. Now I have my data similar to the previous one. It's different data, but what we are doing is the same. And this is a data. Let's check how many data points I have. I have 3,650 data points. Basically, this is a 10-year long data set, and it's a daily data set starting from 1981. So what is the last? 1990, December of 31st of December, right? That is the last data point. Perfect. Okay. Next, what I'm gonna do is, now I know that I can slice my data based on months. I can do that, right? So let's still see what else I can do with this date format. So I can do a lot of things with this date. First thing is, if you like, if you want to deal with months and days, for example, you might be wondering what is the temperature what is the average temperature in months of December? Because now I have 10 years of data set, right? Or maybe later on you might be wondering, for example, this data set might be a data set of instead of temperature, we might have purchases, right? Purchasing amounts. So how much sales a company made per day, right? So you might be wondering what is the average purchase in the first day of the week, in the second day of the week, in the third week of the day. Okay. Now this is going to be a lot. We're going to deal with in more detail later on. So you can look at the purchases on weekdays, as well as how each weekday purchase is changing across different months. So you can look at seasonality in your data set. So that's going to come later, all right? But for now, can I break this date into month and day, so that later on maybe I can use month and day separately? Okay, so that's the next thing we're going to learn. So let me get rid of this side so you can see my screen better. So what I'm going to do is I will create a new column. So this is my data frame. I'm going to add a new column. So the way to add a new column is just type the name of the new column in a square bracket. So this is the name of the new column, which is called month. All right. Okay. So before doing this, I'm going to show you something that you can use, but there are different ways of doing this. But before doing this, let me first show you, let us first take the first, what is that? What is that? Index value. So this is index. Okay. These are the indices. I'm going to take the first index, index 0. That is my first index value. Okay, so let's make this head. 1981-0101. Okay, so can I take only the year part of this? Okay, that is the question. So yes, I can do that. Now, remember, this is a timestamp. Its type is date type. Okay, so date time has certain attributes. One of these attributes is year. So I only now took the year part of this index. Again, this doesn't have to be the index. It can be any column as long as it is a date time format column, a column of data type of date time. Then I can always take the year or month. Okay, I took them. That is the first month or day. Okay, so as you see now, I can separate my data and my date into year, month, and day. All right. So what I'm gonna do is I'm gonna add a new column called month. I will take the month part of each index value. So again, there are different ways of doing this. One way is I'm gonna use, I forgot the term for that. I'm gonna use, what is the term for that? I will just run a for loop in a list, comprehensive list. Okay, list comprehension. You know what list comprehension is. If you don't, it's okay. Okay, if you don't, it's okay. But this is something you will be using a lot in your daily operations. Like when I say daily operations, when you're typing your code. So what I'm gonna do is for I in range of my data frame. So when I do this, I will be changing in an iteration. I will be taking 0 value, then 1, then 2, then 3. So basically, range of df, actually, length of df. So it is from 0, starting from 0 to all the way to 3650. This last number is not included. Yeah, I forgot to put length in here. Okay. So basically, I will be iterating over all the rows of my data. Okay. Then next is what I'm going to do is I will do this the df.index, df.index. Okay. And this will be the ith index. And then if I put this in a list like this, so what's happening here is, let me run this for you first. And by the way, I know there's one thing missing here. I know that. So if I run this, as you see, it is first I is the 0th row. It's taking the first index. Then I is the second row. It's taking the second index. Okay. So I'm taking the index of each row one by one. That's what I'm doing. And then from each index, I will only pick the month portion. Okay. Now if I do that, as you see now, I'm picking only the month portions. First, month 1 is, right? Month is 1, then 2, then 6. Okay. Yeah. Let me get rid of this. Let me run this. Now let's see how df looks like. Now you see I added the month column. This is the first, so it's the first month, so it's gonna be 1. Now let me also add the day column. It's exactly almost the same. The only thing is I'm gonna change month into day. This one will be day. You can give any name here, but this has to be day. Okay. So this is the name of the column. This is the name of the attribute. It has to be day. Okay. So I'm done with this month and day business. Now we'll do more interesting things with day and month. Okay, so let's see how our df looks like. Now I have the day as well. So I picked date, I'm sorry, the month and the day. Okay. Now we are going to see why we are spending so much time with this. Later, we are going to do this later. Oh, by the way, I missed some questions here. Yeah, df month is df index month. Michael, we can do exactly. Yeah, let me write what Michael is suggesting. Df, yeah, I said you can do this in different ways. Let me call this month 2, okay, is equal to df dot index. Index is the time itself, the whole thing. Just pick the month part. That will also work. That will also work. So this is much simpler. Thank you. I just wanted to maybe do this the hard way to talk about list comprehension, but this is much more easier, and you can do the same thing. Thank you. But let me drop this one. Here also, let's learn how we can, right now I want to drop month 2. So what we can do is we're just going to drop month 2. Let me put this in a square bracket. You don't have to, but if you want to drop multiple, you have to. And then let's make this in place. Now what I'm doing is I'm going to drop this one from my data. Oh, and then I need to say access. Okay. Again, let's say. Yeah, I dropped month too. Thank you. Okay, thank you. So let's continue. Let's continue. So what I'm going to do is, so from time to time, when you are dealing with time series data sets, for example, let me give you a problem. For example, this is one project I spent maybe 2 years on. I give you I'm getting rental numbers, okay? And then you are going to predict tomorrow's rentals using or today's rentals using yesterday's numbers, or you're going to predict tomorrow's rentals using today's rental numbers. So if I know how many rentals I gave away, can I use that to predict tomorrow? Okay. So if that is one simple example, okay, you need a data set in which this data set is using yesterday's numbers to make predictions for today, okay, or might be using yesterday and the day before yesterday's numbers to make predictions for today. In time series data set, most of the time what we observe is what happens today is not totally independent from what happened yesterday. So if I know what happened yesterday, I can just use it as an attribute to predict what will happen today, because things will not change drastically in a time series. That's most of the time, that's what we observe. I'm not saying that is always the case. So from time to time, you might need to create another column here. Okay, let's imagine that we create another column here. In this column, for example, if you focus on the second row, in this column, the number that you will see in the second row will be 20.7. So what I want to do is I want to add a new column to my data set, and that new column will represent the temperature from yesterday. Right? In that case, the first row will have a temperature of nothing because there is no yesterday for the first row. The second row will have the temperature of yesterday, the day, and then the third row will have the temperature of the second day. Okay, so for that we are going to be shifting our data set. Okay, shifting our data set. We can shift this by 1, by 2, by 3. We'll see different examples. I saw another, Don was suggesting DF dates instead of index. DF dates I. So let me see. Very quickly. No. Yeah, let me check. Let me check it in a little bit later. Okay. DF dates. You're saying I or index I. Yeah, let me check this. Let me check this maybe during the break time. Okay. Thank you. Thank you. All right. So let's continue. What I'm going to do next is I'm going to create a new column, as I said, which is going to be a shifted version of temperature. Let's do it. So this time I'm going to take, again, there are different ways of doing this. Let's start with the very simple one. I'm going to take my data frame, and I will pick my data frame, the column in my data frame let's call it temperature. So I'm just taking that column, and then I'm going to shift that column. Okay, I'm going to shift that column by 1 day because my unit is day here. Okay, let's see what happens when I shift. Let's see. You see what happens? I took the first day, there isn't any yesterday. That's why it is not a number, right? It's empty. The second day, the value for the second day is the temperature of the first day. Basically, what I did is I took this temperature column and then I just pushed it 1 day down. That's all I did. But it's going to be extremely useful later. Okay, so this This is something you will do frequently when you deal with time series data set. Okay, let's turn this into a data frame. Okay. I'm trying to use very basics so that we know, for example, if I give you a series, can you turn it into a data frame? Okay, now I turn this into a data frame. Again, you see the indices, right? How useful the indices are. 1981, 0101. The temperature, we call this temperature. Maybe we should call it something different. Okay, maybe we should call it something different. Okay, and then I'm gonna, let's say this is my data frame. This is my original data frame, but this is my data frame. I'm gonna call it lag one. This is in literature, actually, this is called lag one version of my original data set. Okay, lag one. All right. And then let me also turn this column name. Okay. This is, for example, what is this? What is this column? It is temperature from yesterday, right? This is the temperature from yesterday. So let's call it this way. df lag one dot columns is, I'm gonna call it temperature from yesterday. Okay, now let's see df lag one dot add. Okay, so this is temperature from yesterday. This -1 means it is from yesterday. Okay, that is the yesterday's number. Okay, let's continue. Now what I'm gonna do is this is something we learned last time. I'm gonna put this column. So what is the number of columns here? df lag one dot um, shape. It has the it has the same number of columns. The only thing is the first column is 0. I'm sorry, not a number. What I'm gonna do is I'm going to put this lag one and my original data set together, concatenated. So we learned this last time. So what I'm gonna do is concatenate. And then this is a list of data frames. The first data frame is df lag one. The second one is our original data set df. Okay. And then I'm gonna assign this back into my original data set. Now let's see how my data set looks like. What happened to my df? Let me run df one more time here. Just 1 second, please. Df day. df lag one. Okay. Oh, I need to say when I concatenate them, am I concatenating them vertically or horizontally? I need to say this is a vertical. Yeah, that's what I didn't do. So I'm putting two data frames side by side. That's what x equals 1 means. Okay, now I got it. So let me make this. So now when I'm looking at my data set, this is my original data set. This is the month, this is the day, and this is the lag one version of my temp column. Perfect. Okay. So what I'm gonna do next is I can create, one or two or three shifted versions of the same data set. I can do that, right? So let's read our data set one more time. I'm gonna go all the way to, so I'm just going to copy this. Okay, let's copy this. I will go all the way down. Okay. Now let me read this first. Okay, now my data frame is just my original data frame. Okay, original data frame. Next, I'm going to say df temp. Okay, shift this by 1. Okay, comma, and then I'm going to shift this. Sorry, I'm going to shift this by 2. Shift this by 2. And then shift this by 3. Okay, right. So if you like, we make this way so that you see everything side by side. Now I'm going to put them into a data frame, pd.data frame, and I will put these guys into a list, and then I will close my data frame parentheses. Now let's see what's going to happen. Okay, let's see what's going to happen. When I run this, look what I will get. So it shifted my temp column first by 1, then by 2, then by 3. But as you see, when I turn it into a data frame, temp is, these guys are showing as they became the rows of my data. Okay, they became the rows of my data. I don't want to see it this way. I want to see uh, um, the years should be my row indices, and temp should be my column indices. Okay, so if you want to do that way, then you need to take the transpose of this data set. Transpose means if I give you a matrix, you just hold from the left bottom point of your matrix, then right top of your matrix, and then flip it. Okay, that is transpose. So let's transpose this. Again, I'm holding from here and holding from the right top of my matrix, and then flipping my matrix here. Okay, so now I have my data frame. Indices are my row indices, and date is my row indices, and temp. I need to change these values. So first of all, let's assign this to a new variable. Let's call this df lag 1, 2, 3. Okay, so I'm just assigning this to a variable so that I can work on that. Okay, next I'm going to take this data frame. Remember, I need to change the what is that, like 1, 2. I need to change the column names. Let's change the column names. The columns are, the first one is shifted by 1, right? Temp is 1. The second one is shifted by 2, temp -2. The third one is shifted by 3, temp -3. Okay, now columns equals df, oh, it's underscore. Okay, now let's see how df lag 1, 2, 3 looks like. Yeah, now I have temp -1, temp -2, temp -3. Perfect. Okay. What I would like to connect this, I would like to put this together with my original data frame. So the original data frame is, remember this one. This is my, sorry, this is my original data frame. I'm going to put my data frame together with this data frame so that I have temp -1, temp -2, temp -3. Again, remember this, PD concatenate. Okay, the first one is df. The second one is df lag 1, 3. Okay, if I do this, what happened? Oh, df. Oh, don't need to put them into. Sorry about this. Perfect. So let's assign this back to what? df. So that's equals, and then df dot head. Perfect. So now I have the version of my data set where, again, I did the same thing. It was 1. So because of that, to read this part one more time. You see, we are making mistakes. I'm making mistakes. Every time the same mistake. Okay, now I got my data. Okay. Oh, by the way, if there are any questions. Yeah, I will share the material from last week. Yeah. So can you not see my screen? So Aramide says I cannot see the screen. All right, so let's continue. I will give a break in 5 minutes, and then we'll continue, okay? So we are almost done with this lag business. Now, once another thing I want to do is let's look at this data set, and let's look at this data set and then think about it. So, what if I want to create another column, and in this column, I want to have the mean of yesterday and today. Okay, mean. So I want to, for example, for the second row, I want to have a value which is the mean of the average of that day and the day before yesterday. So imagine that there is a window. I'm using this word window. So that window is only containing 2 days. Okay, you take the mean of the days falling into that window and then shift that window by 1 day. Now you have again 2 days in that window, but the days contained inside the window is changed. So in other words, every day I want to find the mean of today and yesterday. Every day. Okay. So how can I do the mean of today, yesterday, the day before yesterday? How can I do that? Right. So in that case, again, you can do this. Definitely, you can do this in different. For example, if you want to find the mean of today and yesterday, what you can do is you can take the mean of temp and temp minus 1. And let's try to do this. Okay, plus df. Okay, so what's this? That is, you see, I've just added uh, uh, temp with temp minus 1. Let's divide this by 2. Let's see what happens. Okay, and then let's assign this. Let's make this a data frame. Okay, so I don't want to assign it to. So what I just did is I took temp and temp minus 1, added them up, and divided by 2. So what happened here is, as you see, the first day, the first row, the average is, I took the average, right? Average of 2 entries. Average is NAM because if you take the average of a number and not a number, average is always not a number. Please keep this in mind. If you have n number of values, one of them is not a number, then you take the average, it's going to be not a number. Now, I go to this next day, 0, 2. This time I'm taking the average of, again, if I'm at 0, 2, that is today. I'm taking the average of today and yesterday. Basically, what I'm doing is I'm summing up 17.9 with the temperature from yesterday and dividing it by 2. That gives me the average of those 2 days. So this is one way of finding the average. If you go to the next day, third, again, this is the today's temperature. This is from yesterday's temperature. I can add these 2 and divide it by 2. So this is one way of finding the average of today and yesterday as you move down the indices. Okay, imagine that there is a window here. The window is containing 2 days. Find the average of those 2 days. But the thing is, window begins when you are in the first day. Window is covering this one, and it assumes that there is another number above to 20.7, but there isn't any number above 20.7. That's why the average of 20.7 and the number before it, which is nothing, is nothing. Okay, that's one way of finding the average of today and yesterday. Okay, that's one way. We can do this in different ways. That's what now we are going to learn. Okay, that's what now we are going to learn. Again, let's maybe it is time. It's good time now to take a short break. So it's 10:55 my time. So let's meet in 10 minutes. Okay, so past 5. Let's meet at past 5.
Hello, everyone. I hope you guys can hear. So I will make a brief announcement. So Dr. Jaran has been giving this workshops for a while. I hope it's been benefiting all of you. So as a Magnimind Academy, we're gonna try to keep up with these workshops. Hope to enrich our community as much as possible. And one thing we are starting soon in mid of June. We are starting a new batch for our mentorship/internship program, where we is a new kind of a boot camp where we assign students 4 to 5 mentors, and we partner them with companies in Silicon Valley, our partner companies, where they work on real projects. This is a 15 weeks program where you guys first do a 6-week accelerated projects on learning how to build machine learning and data science projects. You learn how to build a full pipeline project. And the following 9 weeks, you guys work with companies where you work on real life projects, where you can also use that as your internship experience in your job applications. There's been really been asked by our students for a long time. We've been doing that this year and some part of last year. And this is just to accommodate students' needs for getting an experience, real company experience, where also need for a lot of recruiters are asking for. So if you're really interested, we just share those programs website and then our email in there. And you guys can look at the website, and can you look at our short or long videos about this, info videos that our friends will share. You can send us an email if you like to learn, if you're fit for the program, because we're looking for some certain background of people. They just really need that kind of completion in their training to get jobs or land jobs in data science. And yeah, please let us know. And I hope to continue working with you. We'll have those events continuing, and we'll have us in person. So we have actually started additional batch for June. So that will be a new batch. This was we'll start additional batches for June. Thank you.
Okay. Hello, everyone. Let's continue. I just shared the material from last week, right? And Amrit is asking if I can provide an example of signal processing. I spent 3 years of my life with signal processing, but it's been a long time, Amrit, since I did signal processing, right? I think you can easily use what we are discussing to signal processing. Again, we are at the very beginning of time series discussions. So what we are discussing here, you can easily use it for signal processing. Actually, there is one thing that we're gonna use maybe like 30 minutes later. So we can create a window of for our data set. The window is taking a triangle mean of say 3, 4 data points. That's basically what we used to do for signal processing actually. Anyways, yeah, it's been a while since I did signal processing. So let's continue. What I'm gonna do this time is, again, if you already created lagged version of your main data, you can find the mean of 2 days, 3 days this way. Now let's try to do this in a more Pythonic way, okay? So again, we are going to again begin from we are gonna do this from the beginning. I'm going to read my data, so not removing anything. Okay. Okay. I will copy. I will copy this one. Please copy this one. DF. Copy this one. Right. Normally, I will type and type again and again just for practice, but we don't have time for that. Okay, so that is my original data set. Now I'm gonna create a shifted version of this data set. We know what it means, right? So what I'm gonna do is I'm gonna take my data frame, temp. I know that we have this temp and then shift one. We know what this is, right? We know what this is now. So I'm gonna create this, put this into a data frame. Again, you can do all this without putting into a data frame too, but let's go step by step. Shifted. I'm gonna call this shifted. Okay. Now, if you look at, let me add some. If you look at shifted, this is what we have, right? So that's the shifted version of my original data set. Now, what I'm gonna do is I'm going to take this shifted is this data frame. It's a data frame. This data frame has a method called rolling. Okay, it has a method called rolling. So inside rolling, there is one parameter called window. Now you know what, when I say window, you know what I mean, right? Window is this box in which, so if you consider only today and yesterday, window size is 2. Okay, window size is 2. So every time I'm looking at the data set, okay, I'm considering 2 data points falling into that window. Okay, and then that window will be shifted. Okay, now if I run this, I just created one new object, which is a rolling object of my shifted data set with a window size of 2. Right? Let's see what I can do this window. So I'm gonna assign this to a variable called window 1. Okay, let's call this window 2. So this is window of 2. Okay, now I am going to I just wanted to point this out one more time. As of now, I'm not making any calculations. All I did is this window 2 is actually I just prepared the environment. Okay, so what window 2 is, this data, shifted data, not any other data, this shifted data. And this shifted data, I define the size of the window. There is a window of size 2. Okay, there is a window of size 2. All right, so this shifted data and then a window of size 2 are ready. Okay, are ready waiting for me. That is window 2. Now I can do some operations on this window 2 object. So window 2 object, what I'm gonna do is, look, I'm gonna take the mean. So let's see what happens now. You see? So the window actually is starting from here. Okay, starting from here. So it is, the window is covering 0, 1, 0, 1, and anything above it, which is nothing. Then window of 2 is shifted by 1. Then window of 2 is covering these two dates, 0, 1, 0, 1, 0, 1, 0, 2. Then it is shifted one more time. The window size 2 is covering 0, 1, 0, 2 and 0, 1, 0, 3. Okay. And each time I'm taking the mean of all the numbers in that window. So now you see two NaNs. The reason is because when I shifted, the first value is NaN. And if I take the average of this with anything before, it's NaN and nothing. That's why it is NaN. The second value is also NaN because now I'm here on the second one. When I take the average of this with previous one, again, the average will be NaN because a number and NaN, average of a number and NaN is NaN. When the window is shifted one more time, this time window has 20.7 and 17.9, and then that is the average. So please keep in mind, the first time window is placed on my data frame, okay? If the window size is 2, the second, so at the bottom of the window, I have this first row. Okay, that's how it begins. That's how the window is shifted. Okay. All right, because I haven't centered my window. Now, let us take this window to mean and then assign it to a variable called, say, means. Okay, now I know what means is. Now I'm going to, take my data frame. Okay, I'm going to take my data frame and then put them together. So what I'm going to do is, so where is it? Where is the shifted? This is shifted. I will put shifted. Let me put some more. Yeah, we'll spend a bit more time with this window business, right? So I'm going to concatenate this means, which is right this one, and then shift it. And then access is 1. So let me run this and then see what happens. Now I see this is the shifted one, this is the mean, right? So I need to give the names, right? So let's call this df lag 1. Okay. And then df lag 1, right? Columns. Okay. Is equal to, I'm sorry, is equal to. So the first column, I will give the name. It's the mean of t and mean of, I start from t minus 1 actually. T minus 1 and t. Okay. All right. And then the second column, this one is actually, it is t minus 1, right? It is t minus 1. Okay, let's see. Okay, so that is the mean of, so if you are here, let's say this is t, wherever you are, that is t. So this is, so let's look at the third one. This is t. This is the mean of t and t minus 1. And the next one is, if you are at t, the next one is the value of t minus 1. Okay, so this was, if you also, yeah, let's also put the data frame here too. So this time it's gonna be t. The data frame is, yeah, but that's gonna be a lot better now. Yeah, now you see everything together. Again, when you are in the 3rd of January, that is t. Let's say that is t. Wherever you are, it is t. So that is the mean of t and t minus 1. The next one is the value of t minus 1. T minus 1 means if you are at t, t minus 1 is 0, 2, right? So this is the value of yesterday. The next one is value of today, which is t. All right. So we just created a rolling window. And then from that rolling window, we took the mean of the rolling window of size 2. And then we took the mean of that window, right? That's what we did. Okay, perfect. Now let's let's continue. Let me see if you have any questions. Yeah, I'm gonna this again. I already shared the material for today. Those, if you just joined now, so I shared the material for today. Okay, I will share the material for today one more time. If you just joined, okay, this is all right. This is from for today. Okay, let's continue, guys. So again, we can do this more professional looking. So I'm going to copy this one more time. Okay, one more time. Let's do that. Okay, here. Okay, that is my data set. So now I'm going to say the width of my window is, let's say, 3. And then I'm going to create shifted as pd.data frame. I'm going to say df. I'm doing the same thing. Okay, temp. I'm shifting this by width -1. So, again, this is just a way of telling that later. So I just created shifted as width -1. Okay. And then I'm going to create window as shifted dot rolling window equals width. So let's see what happens if I do this. Let's see what happens if I do this. All right. So when I run this, first of all, I am shifting my data by and then I size of 3. That means this time I can take the mean of 3 data points. But this time I created 2 lagged version of my data sets. Okay. So is the following. I'm going to take this window. I'm sorry, window. You know what this window is? Window of 3. And this window is operating on the shifted data set. That shifted data set here. First, let's write shifted. That's head. You said this shifted data set is shifted by 2, not 1 anymore. Okay, 2 lagged. Okay, so I'm taking the mean. I will take the mean of, say, 3 data points, but not just mean. I'm going to do more than that. So I'm going to take window, which is window of 3, okay, on this data set, and then I will take the minimum. So what does that mean? When I take minimum, what happens? You see, this time what happens is the window is of size 3. So the first time the window, the data frame, only including the first one. So there aren't any above that. I'm looking for 2 more data points because this is only one of them. I'm looking for 2 more data points, which they're not there. Then the mean of not a number is not a number. Then I shift my window by 1. So this time my window is right here, 0, 1, 0, 2. So there are 2 dates in my window, and there is 1 nothing in my window. So nothing, date 1, date 2. The window size is 3, so there are 3 things. Again, minimum of 3 nothings is nothing. I shifted by 1. Now my window is including the first 3 data points, but the first 3 data points have 2 not a number values. Again, the minimum is not a number. See, I'm right here. I shift my window one more time. This time I have 0, 2, 0, 3, 0, 4, okay, in my window. Again, minimum of these three is nothing. All right. You see, the first four window min data points are nothing. I shift my window one more time. Finally, in my window of size 3, I have 3 valid values. The minimum of these 3 values is 17.9. It is 17.9. So I just found the minimum of 3 numbers falling into my window. So I can, in addition to this, I can find the mean of these 3 numbers, and I can find the maximum of these 3 numbers. Right? Okay. So what I'm going to do is I'm going to concatenate these guys with my original shifted data set. Not original, the shifted data set. So I'm going to concatenate these guys. PD dot concatenate along the axis 1. That means I'm putting them side by side. And then close the parentheses. Let's see what's going to happen now. Okay. Wow. So this is my shifted data set. This is the maximum. This is the average. And this is the minimum. As you see, the first 4 data points are all not a number because the first 3, these first 3 are windows. The last one is shifted. The last one is shifted by 2. That's why I have to two values, not a number. Right? So then let's also give the, what is that? MDF is this. I'm going to give column names to this. MDF dot columns equals. So that is minimum. And the next one is mean. The third one is maximum. And the fourth one is, what is it? The fourth one is T minus 2, right? T minus 2. Okay. DF dot head. Let's look at the first 7 numbers. Okay. Perfect. You see, this is T minus 2. I can even, let's also put the original data set too. And this will be T. So I hope you guys are following. So this is my original data set. This is 2 shifted version of my data set. This is the maximum of my data points, original data points in a window of 3, but not original. Sorry, 2 shifted points. The reason why I'm spending time on this is, depending on what you're trying to solve, you might want to create, shifted version of your data set. You might want to, for example, I'm gonna predict tomorrow's sales. Thank you, Charles. I'm gonna predict tomorrow's sales. As an input to my model, I will use the mean of the last sales of the last 3 days. Okay, again, I'm gonna predict today's sales by using the mean of the last 3 days sales. So in that case, I need this mean column. All right, I need this mean column. So you can also need minimum and maximum of last 3 days. That might also help you to determine something. Maybe between this minimum maximum, you're going to interpolate your data, right? So you may do a lot of different things, but again, before even talking about any time series models, we need to be comfortable with making these changes in our data set. Okay, we need to know what it means to shift, what it means to create a window and then taking minimum, maximum falling into that window, right? Maximum of data points falling into that window. Okay, let's continue. What if, that's another thing you will see that you are going to be doing, okay? What if not taking the mean of the 3 data points in a window, but as I move down, so, right, I want to use, let's say, again, I'm predicting sales of today. One input to my model is mean of the average of the last 3 days. Another input might be average of all the sales up to that point. You got it, right? So for example, if you are here, average is say 20.7. If you are here, average is 20.7 and then 17.9, average of these two. If you are here, the average is average of these three. All right. So you are taking average of everything, say up to that point, let's say. Okay. Can we do that? Can we do that? Or average of last three, very similar to window. Okay. Can we do that? Let's see. Okay. So what I'm gonna do is I'll again copy this one. Again, going back to our original data set. Yeah. Okay. So this is my data set. Again, let's remember how it looks like. Always let's go step by step, all right? And then I'm gonna take the temp, okay? I'm gonna take temp. If you just take this, it's like it's a series. If you do this, it's a data frame. This is a data frame, okay? I just picked temp. And then I will say temps. Okay, I know what temps is now. So I'm gonna say temps dot expanding. So let's see what this does. I'm just curious about it. Okay, let's see. So again, it's an object which I can do things on this. Let's say expanding mean. So let's see what's gonna happen. So this time, remember, this is my original data set. I'm expanding and then taking the mean of my data set. So it is basically 20.7. The first number is 20.7. The second number is 20.7. It's 19.3. So I'm just curious, what is 19.3? Let's see if 19.3 is the following. Maybe it's 20.7 plus 17. So let's be more times 0, right? So times it's 20.7. I'm going to take the average of 20.7 and 17.9 actually. Yeah, let's just use the numbers. It's gonna be, I don't want to get into mean and average for data frames. Let's just use the numbers. Be very simple. 17.9. Sorry about that. Okay, I'm just taking the first two numbers and then taking the average of that, 19.29. Okay, now I'm gonna add the third number, which is 18.8, 28.69. So basically here, it didn't take the third number, right? So this is still 19.13. So what happens here? What is it doing then? So it is not taking the average of the three numbers all the way up here. Maybe it is taking the average of the first two numbers. Divide 3 by instead of, oh, I'm sorry. Divide 3 instead of by, because I'm taking the average of three numbers. I'm confused. It's still 18.5. So it should be this one, right? I'm talking about this one. So, oh, this is 20.7. 20.7. Yeah, I was confused. Thank you. So I'm taking the average of the first number, 20.7, average of the first two numbers, 19.3, average of the first three numbers, 19.13, average of the first four numbers, and then this will be the last example, okay? Four numbers, it's 18. So basically, expanding is, in this case, I'm taking the mean. It is taking the mean of all the numbers, including that point, okay? For example, if you are at the third row, expanding that mean is going to take the mean of all the numbers, including that row, okay? Up to that row, not up to that row, including that row. So you can use mean, you can use maximum too. So this time it is the maximum of all the numbers. Let's say you are at 1981-01-04. This is up, let's say this is the day you are at. You're wondering what is the maximum says up to this point, including today. Okay, so that would be in this case 20.7. So that is expanding. Now, if I make this, let's go back to mean. That's where I was confused. If I make this, let's see, so this is mean, okay? If I make this 2, then what happens? Then what happens? So expanding 2. Why the first number is, what is it? NaN. And the second number is 19.3. So let's find out. So what I'm gonna do is 20.7 plus 17.9 divided by 2. Okay. So it is 19.3. So the second one is this one is average of the last two numbers. Okay. If I go to the next one, it's gonna be average of the last two numbers again. Okay, 17.9 plus 18.8. 18.35. So again, I'm a bit confused here. 17.9. Yeah, I need to use the previous one. Sorry. So 17.9 plus the first one is not a number. Second one is average of these two. The third number, I'm right here. But this one is average. This one is not a number. This one is the average of these two. This one is supposed to be average of these two. Plus 0.8. Okay, let's go. Let's make one more. 18.8 plus 14.6. 7.7. I'm a little bit confused here. Just 1 second. Just 1 second, please. I'm right here, 18 point. If I'm right here, this is 1, 2, 3, 4. Okay. Let me check this for you, okay? I'm a little bit confused with this expanding to dot mean. So let me check this one. Okay. For I need 1 or 2 minutes to check this one. Let's continue. Maybe during the time I will figure it out and then we come back to this one. But expanding, so let's exclude this one. So temps dot expanding dot mean is going to give me the mean of all the numbers from previous observations, including the number that I am at now. Okay, so that will be very useful, right? So expanding 2, I will get back to it. Okay, let's continue. Let's not waste your time. Okay, so that is another thing that I wanted to show you. Now, next one is, yeah, Paulo, minimum number of window required to have a value, otherwise results, yeah, NP, yeah, that is for sure. That is for sure. So I was trying to figure out when expanding, so this one, I'm trying to figure out how these numbers are coming out. I'll figure out in if I had 1 or 2 minutes. Right now, I don't want to waste your time. So let me continue. So what I want to do next is I would like to create a linear regression model, train a linear regression model, very simple linear regression model. Okay. So in this linear regression model, what I want to do is I want to predict tomorrow's temperature using what is it? Yesterday's temperature. Okay. That's all I want to do. Right. That's all I want to do. So let's go back to this window business here. I'm going to, where is it? This one. I'm gonna use this one, okay, tempdf. So let's call tempdf one more time. Tempdf.head. This one, right? So this is my original data set, and this is the data from yesterday, from 2 days before. Let's add yesterday as well here, okay? Let's add yesterday as well in here. So let me copy this one so that we know what we're talking about. I'm gonna bring it over here, and I'm gonna say shifted is by 1, right? This shifted is this one, right? By 1. So I'm going to create shifted 2. Okay. 2 times. All right. This is shifted 2. This is shifted 1. So this is shifted 2 times. This is shifted 1 time. And this is shifted 2. And this is shifted 1. Okay. And then this will be t minus 1. And this is t. Okay. So I have my data, original data, shifted by 1, shifted by 2. Maximum, mean, and minimum of a window of size 3, right? Okay, so that is my data. I have, as you see, not here. Let's be very simple. Let's be very simple here. Let's not deal with these missing values. And then let's get rid of these missing values. Again, how can I get rid of the missing values here? What I'm going to do is I'm just going to select the rows with missing values, and then I'm just going to eliminate them. So what I'm going to do is I'm going to take my temp df. From this temp df, which values are missing? Okay, so if I do this, it's going to give me exactly the same data frame, only with Boolean values. A true means missing, a false means not missing. So here I can easily see which values are missing. All the true ones are missing, right? So, and then from here, what I want to do is I will only pick the rows which has at least one missing value. In other words, which has at least one true value, okay? So, and then for indicating that I'm picking the rows, I will select the, what is that? But in this case, if I select select this one, let's see what's going to happen. It is telling me which of the rows have at least one missing value, okay? Which of the rows have at least one missing value. Now, what I'm going to do is I'm going to select all the rows which have false value. False value here means this row is not missing any value, because I'm checking here which rows have missing value. If it is true, that means this row is missing at least one value, right? That's what you see here. This row, the first row, has 3 missing, or actually 5 missing values. The second row has 4 missing values. So if a row is missing at least one missing value, this will return true for that row. So here I need to check all the rows which have false value. So what I can do is I can turn all the falses into true, all the trues into false, right? Now, if it is true, because I added this tilde at the beginning, this is not, right? If it is true, that means that row is not missing any value. Now, from my data frame, I'm going to pick only the rows which are not missing value. Okay, and missing value, tempdf, sorry, tempdf. As you see now, I start from the 0, 5, because that is the only row, that is the first row without any missing value, actually. Okay, so again, I wanted to go step by step just to learn together how we can eliminate rows with missing value. You can eliminate the columns with missing value, but it's not going to be so useful here. If you eliminate columns with missing values here, you're going to go back to the original data set. I don't want to do that. Okay, so let's say this is temp df2. Okay, so that is the data set without any rows with missing values. Okay, now I'm going to just import from sklearn linear model. I'm going to import linear regression. Now we started making prediction. This is the very first basic one. We're just going to create a simple linear regression model. Let's instantiate this linear regression model. linear regression. Okay. And then what I'm gonna do is my data set, right, has data. The data frame has what is that? Features and the label. What is my label here? What am I trying to predict? What am I trying to predict? Using yesterday's, in this case, so right, let's say this is today. This is today. I'm trying to predict today using yesterday, right? I'm trying to predict today using yesterday. The input to my model will be the temperature from yesterday. What I'm trying to predict is today, right? So let me print without any missing value so that you guys are not going to confused. Again, this is my data set, okay? So this is today, this is yesterday. In my model, I will use yesterday's temperature to predict today, right? So that's why what I'm gonna do is my feature set, which in machine learning, we use capital X for feature set. My feature set is going to be this one, okay? T minus one, that is my feature set. So my, what is that? Temp df2 dot, let's use this one, T minus one. Okay, so this is my feature set. What is my target variable? Y. We are using small y for target variable. Temp df2 today, right? Again, I'm using yesterday's numbers to predict today. Okay. Let's see. Now I'm going to train my linear regression model, linreg1 dot fit, right? I will fit using data and label. And then it gave me an error. Let's see. Okay, just 1 second. Yeah, so it is expecting from us what is it? Two-dimensional array. So that is what scikit-learn sklearn does. Again, this is something other than time series, but sklearn is expecting from us a two-dimensional array, but our array is now single dimensional. I think we can easily fix it. There are different ways of fixing it. We're just going to add a new axis to that. It's not on top of my head how we can add a new axis to our data frame. Maybe you can help me to do that. So how we can add a new axis to our, in this case, this x. So x is now, it's a series of a single dimension. Okay, I'm just going to add one more dimension to this. So can we reshape this? It's not going to work because it's going to say, let's see, but it's not going to work. Next change. One. Because it's a series. So let me. No, it's not x index dot x date is not gonna work. So I think I figured it. Just give me 1 second, please. Yeah, it worked. So what is the dimension of x new? And this is yeah, it worked. So here is what I did. Again, there's a simpler way of doing this. I couldn't remember now, but there is a much simpler than a simpler way of doing this. X is, as of now, here. You see, this is not time series, right? But it is a problem. We just faced with that problem. X here now is, if you look at X, it's a series. It's like one column of my data frame. So I'm going to add another dimension. If you look at the dimension of X now, shape, you see it's a single dimensional array. Okay, it's a single dimensional structure, right? So I'm gonna take the values of X. If I take the values of X, it's gonna be an array. Now this is a NumPy array. I can reshape it. When you reshape an array, you can reshape it into a matrix of the same size. I mean, when I say same size, same number of elements. So when I'm gonna reshape it, all I have to do is, what is the number of here? I know that this is sounding a little bit, if it is the first time you are seeing, it's sounding a little bit confusing. This is the shape, right? This is the tuple. So I'm gonna reshape X into this. I'm not changing X anything. I'm just adding one additional dimension. That's all I'm doing. See, this is a single dimensional array. This is a two-dimensional array. Okay. So I'm reshaping X by taking its values. Now this is a NumPy array. Now I'm reshaping it into this. What is 3646? X dot shape 0. X dot shape 0 is number of rows in my data set. So X dot shape 0, comma. What is the second dimension? It's just 1. So it's gonna be just think of it as a matrix, like a long matrix with a single column. Okay? That's what I did here. Now you see this is the first element, 14.6. This one, it is the first element, and then the first row. This is the second row. This is the third row. It became a matrix with n number of rows and one single column. Now we trained the model because XNew is a two-dimensional array. And then I'm going to use this model to make my predictions. Remember, this is my data set. Where is my data? Temp df2. Temp df2. Please remember this. For example, if this is today, 06, if that is today, 06, I'm trying to predict the temperature for today. This is the real value, but I want to predict, okay? And how I'm gonna predict? I'm gonna predict today's value using yesterday's value. Did I make this 15.8? Hold on, did I name it wrong? df shifted 1, 2, 3, 4, temp df2 t. So there's some confusion here. Hold on a second. Where is df? Okay, this is df. All right, and then shifted by 1, by 2. Windows mean, Windows maximum. Shifted 2, shifted 1, and df mean t minus 2. Okay. Yeah, now it is. Oh, I see. I was expecting to see this as the first number. Now I see that we already eliminated the empty, the not a number. So I eliminated this first. So that's why I was confused. I was expecting to see 20.7. Because I didn't see it, I was confused. I think I'm getting tired. So actually we eliminated these rows, right? That's why I don't see. Okay, I thought we made a mistake. Okay, we didn't make any mistake. So this is, let's say we are at 00109. Let's say this is today. I'm gonna predict today's number using yesterday's number. Here, yesterday and today were the same. That's why I was confused. Okay, I'm gonna predict today's number using yesterday's number. So I will assume that I don't know today. I know only yesterday. If I only know yesterday, how I can predict today? That's what we are trying to do here. So that is our model. Now it's time for us to make predictions. thin reg 2 1, right? That is the name of the model. Yeah. Now let's predict. I'm going to predict given x new, right? So x new underscore no. Okay, let's see. You see, these are my predictions. These are my predictions. Okay, these are my predictions. So let's make this, let's turn this into a data frame. Okay, and then okay, so these are the predictions. Let's call this red. Okay, now let's concatenate this with our original data set, tempdf2. Okay, this one. All right. So what I'm gonna do is pd.concat tempdf2, df2, and then comma. There is no need for this. And then thread. And then this is x equals 1. Okay. Now, I see. So you see, did you see what happened here? Confused about the regression? Oh, Charles, you are showing the. So you see what happened here? I tried to put my predictions next to my original data set, and then I got this one. So what do you think happened here? What do you think happened here? When I want to concatenate them, the indices of my first one, the indices of my first data, right, as actually time. The indices of my predictions is not time. All right. So that's why I couldn't put them together. All right. That's why I couldn't put them together. So you can take care of this. You can just assign the same indices to the second column and then put them together. But for now, let's look at this. Temp df2 t. Okay. Mm. Let's say up to 10. Okay, comma. This is 0, 1, 2, 3, 4, 5. Okay. Okay, see, these are the temperatures of the first 10 observations. Okay, these are the temperatures for the first 10 observations. Yeah, I can convert the result to NumPy array. So that's actually the result is in terms of NumPy array. Actually, the result is already in NumPy array, Fatima. So now I will also take my predictions. This is the result, right? This is already. I changed into data frame at first. Okay. So here is the first 10 observations. So these are the first 10 temperatures, and these are the first 10 predictions. So I predicted the first one, which is 15.8, to be 13 point. This is my prediction. This is the true temperature value. This is my prediction. This is the true temperature value. So when I'm predicting, I'm using yesterday's temperature to predict today. So that's what we did from the very beginning. We prepared our data set to train a model. So this is our preparation. Okay. We prepared our data set. This will be my label. This will be my feature. So if you like, you can use temperature from yesterday, maximum, mean, or minimum. So, okay, let's do one thing. I'm gonna stop in 5 minutes. I know that I feel a little bit tired today, so you might be also tired. I'll stop in 5 minutes. So what I'm gonna do is I'm gonna find the mean squared error of my model. So from sklearn.metrics, I will import mean squared error. Okay, so this is going to give me the mean squared error of, this is basically measuring how much error in between my predictions and the true values. Okay, so mean squared error between, in this case, y. Okay, y, and then predictions values. So that is the mean squared error between what I predicted, what it was actually. Okay, so this mean squared error is, I'm taking each of the temperature and my prediction for that temperature, subtracting these two, taking the square of that subtraction and adding up. So along all these 10 years of temperatures, I'm finding the difference between my prediction and the true temperature value, take that difference, squared it, and then add it up for 10 years and take the average of that. That is mean squared error. So before leaving, I want to do one more thing. Okay, I want to do one more thing. So let's copy this very quickly. Okay, very quickly. This is not going to take too much time. Just to see. I know that it might improve the model, but just to see. So this is a second linear regression model. Okay, so this time X is here, X, right? So X will be, I will drop T from my data set. Okay, this is X2. Just give me 5 more minutes and then I'll let you guys go. That is my new data set. Now you see it has 2 dimensions because I used drop. I simply kept it as a data frame. Earlier, I didn't do that. Earlier, I only selected a specific column. That's why I had to reshape it. Now it's going to be simpler. Now I'm going to train my model that fits X2, Y. Okay, this is my new model. Okay, linear vector is not defined because I didn't do this. Okay, all right. Now I trained my second model. Next, I'm gonna make the prediction using the second model. Prediction 2, linear vector dot predict X2. Now, this time, rather than using only yesterday's temperature, I used yesterday's temperature, the day before yesterday's temperature, maximum of the last 3 days temperature, mean of the last 3 days temperature, and minimum of the last 3 days temp. I just added 4 more attributes into my model. Okay, that's all I did. Oh, this is not a good model. This is not a good model. There are a lot of redundancy here. But anyways, you will see that I just wanted to see if my mean squared error is going to get reduced. Okay, that's what I want to see. That is my prediction. Next, what I'm going to do is, again, the same thing I did here, mean squared error. This time, I'm not going to use values here because prediction 2 is already a numpy array. Okay, please make sure that you know the difference between these two. Mean squared error. 6.17, 6.61. You see, slightly, the mean squared error is reduced because I'm not only using yesterday's temperature, I'm also using the day before yesterday's temperature. All that mean and max is not going to be so meaningful, but still we are using the mean of the last 3 days temperature may be also helpful. So I just added 3 additional, 3 more attributes to my model, and then just to see that if my model performance is improved, it's a little bit improved. All right, I will stop here. So thank you so much for your patience. Thank you for listening. So there is one open issue here. I was confused. So I'm going to check it. And then after I fixed it, I'm going to post it, this file. I'm going to put it into the same folder. And then before I put the file, I'm going to put a note in here. So which one? Just one second. There was one point here which I was confused. This one, yeah. I will check this one for you. Okay, I will figure this out for you and then put a note in here so that you will know why I was confused. So, and then I will post this file into that folder. Okay, thank you for listening. And then I wish you all the best, right? So if we have a third session, I'm not sure if we're going to have a third session, but I have third, fourth, fifth session already prepared. If we have a third session, then we're going to announce it. Okay, you will hear from us. Thank you, and then have a nice day, nice evening, nice night. Okay, good night. So see you next time. Okay, bye.